So good evening, everyone. I'm uh, I'm here to talk about Ruby on serverless. This is how we can build our Ruby services using the serverless framework. So a little about me. I'm a technology lead for Smart, which is a financial startup in Singapore. I'm also an open source contributor. I contributed to Ruby on Rails, or rather was, because I haven't touched Rails for a few months now. Some other projects I've contributed on is Netflix Fast JSON API and the framework called Hanami. So let's talk about serverless. So when we talk about serverless, it doesn't mean that there are no servers. So serverless computing still requires servers. The servers just are managed by your provider. And you as a developer do not need to be aware of them. So no need to provision, no need to tweak configuration. You just deploy your code and it's up. You also don't need to think about concurrency in your code. Since your infrastructure is managed, your services will auto-scale based on load. And also, you are charged based on usage. So, unlike if you're trying to provision on EC2 or ECS, wherein you are provisioned or charged on a monthly basis, you are billed on a meter basis based on usage. So, if we want to build a service, a Ruby service on serverless, what do we need? The first thing we're going to need is the serverless framework. We're going to be deploying this in AWS Lambda. And for our database, we're going to be using AWS Aurora Serverless, which is a serverless database as well. To communicate with that database, we're going to be using the AWS Serverless Data API. And since Lambda only supports Ruby 2.5, that's the version of Ruby we're going to be using. And because I love to use Docker, we're going to be using Docker. So let's walk through some code. So the first thing you need to do is set up what you call a serverless manifest. It's a file called serverless.yaml, and you need to describe the configuration of your service. So at first, you need to have a service name. For this example, we're going to be building a Hello World application. We're going to need to specify the name of the provider, and we're going to be using AWS. For our runtime, we're going to be using Ruby 2.5. AWS Lambda supports a lot of runtimes. There's Node, there's Java, there's C#, and there's also Golang, and Python as well. Ruby support for Lambda is relatively new. It just came out a few months ago. So now we're allowed to use Ruby when building our Lambda services. Now, one thing we need to consider as well is where do we deploy our service. So if you are familiar with AWS, there's a lot of regions available. For this particular case, we're going to be deploying this in Tokyo, only because there's no Philippines available. And stage, think of it as your Rails environment. So you can specify dev, staging, and production. So we can also specify our memory size. So one thing to consider here is that if you look at 128 MB, it might look a little small. But since serverless runs on a function basis, and those functions we will try to keep small, 128 MB should be more than enough for applications. Of course, if you're building a Rails application, this is not going to do. But since we're building small unit functions, 128 MB is more than enough. We can also pass environment variables to our functions or our services. And since we want to build an application that doesn't just print hello world, and we want to communicate with the database, we're putting in the database credentials of our Aurora serverless. Also, to be able to communicate with the DB, we're going to be putting in some IAM roles. So the first set of rules is to allow our function or our service to execute statements on the DB. And the next set, the next set of rules is to allow our function or service to fetch the secrets that we are going to be storing in AWS. Last, another thing that we need to configure is what files to send on our services. So I like to, personally, I like to structure my serverless apps this way. So there's going to be an app directory, similar to how you do it on Rails. And that's just it. Every code that the app requires will be on the app directory. There's also the vendor directory, which will be generated when we build our serverless package. And this will contain all the gems that we are going to be needing for our service. Now, the last part of our serverless YAML file is how we define our services or resources. So the first one would be our hello resource, which will be just returning a hello world message. And the format of this one is when we specify the actual function that is going to be run, we first specify the path of the app. So in this case, it's app handler/hello, which is in here. And we don't need to specify the .rb extension. The next part of this is the actual function call. So for this particular endpoint or resource, we're going to be calling handler hello.call, which looks like this. So we're just namespacing, and personally, this is just by preference. I like to namespace my class files and modules. So here I've opted to namespace the hello with the handler module, just so I know that this is a handler, and this is our function call. Take note that this is required. This particular parameters are required. So if you're building a serverless function or serverless service, it needs to be able to accept an event hash and a context hash. So because we want this service or we want this endpoint to be just simple, we just want it to return hello world. That's just what we are going to do. We're going to return a status code of HTTP 200, and we're going to return a body containing a JSON message called with a message of hello world. And now, how do we deploy this function? So to deploy this function, and again, because I like to run everything inside of Docker, we call this command. And because of time constraints, I'm not going to do a deploy, but, sorry, not that one. So if we want to deploy this, our serverless application, we're going to be running SLS deploy. And just because I like running everything in Docker, we're going to be running it via Docker Compose. And this is what a deploy looks like. It runs in about a minute. And it also shows you the URLs of your endpoints. So right now we have here the URL of our hello function. So we could just go and call that function. So you can see it returns a message called hello world. But obviously, just hello world is not going to be very useful enough. And what we need to do, what we're rather going to do right now, is to build at least 2 additional endpoints on our hello world application. One would be an endpoint or a resource that accepts creating a user. and the other one is to fetch the details of that user. And we're going to just make it simple enough and set a name and an auto-assigned ID. So to do that, we're going to need to communicate with our database. And AWS has a gem called the RDS data service, which we are going to be using. But one caveat of trying to build a serverless application, particularly in Ruby, is you cannot bundle your gems locally. You can't do this in the native OS X environment, only because if you bundle a gem that requires a native extension and you upload that to Amazon Lambda, what's going to happen is the dependency would not match the environment. So what we're going to do now is use a container that reflects the Amazon and Lambda environment very closely. And one such container is the LAMP CI container. And for this particular usage, we're specifically targeting Ruby 2.5. Now to build this, we need to run it inside of the container. And that means we need to run it via Docker Compose inside of our container. Now, for bundle, we're specifying a couple of parameters here, arguments. The most important one is to specify the path. We are packaging our gems inside of vendor bundle, and that's the reason why we need to specify in bundle that our gems needs to go into that path. So if you do this, so what happens now is we get a vendor bundle directory, which is here. Oops, it didn't ignore. But if you try to browse the contents of this directory, what you're going to see is all your gems are packaged inside of vendor bundle. Now that we have that out of the way, let's try to build our endpoint. Now, one thing that that you need to note is that unlike in Rails, you need to parse your request body by hand. And that means to say that the request body will be coming in as string, although we know that that is JSON, so we need to parse it via JSON.parse. And once we get that attributes, another thing that we need to note is that the RDS data service gem is very rudimentary and very bare at the moment. It's very low level. We don't have any wrappers or abstractions at the moment for this, but I am hoping that in the coming months, one gem would arise. Maybe when I'm not too lazy, I might write one myself. So, as you can see, we're actually going to be using actual SQL to insert data into our DB. So here we're using find parameters just so that we don't introduce any SQL injection vulnerability. And now that we have our SQL, we set up the parameters. Again, it's very rudimentary. The RDS data service is very rudimentary in the way that it can't infer the data type of the parameter you're trying to pass, which means you need to specify it via the key. So for this, we're passing a parameter called name with a string value, and we're getting it from the JSON that we parsed earlier. Now, when we want to actually call the database, we execute a statement. So we specify the database, and the database and schema are the same for this matter. And we also specify the resource ARN. So an ARN is an Amazon's resource name. You can get it when you go to the console of your RDS Aurora instance. And we are also going to be passing the secret ARN. So what we're doing here is we're storing the credentials of our database inside of Amazon as well via the secrets manager. And we're just telling our RDS client where to find those credentials. Then we pass in the SQL and the parameters. And after that, we get a response. So the response contains a record, an array of records. And obviously, we're just expecting one record. So we're just going to fetch the first one. And again, we don't have some of the nice things that Active Record provides here. So we're going to be inferring the attribute columns of our result via the position. So take note that we've explicitly specified that we want to return the ID and the name. And in this position, we're going to be getting ID and name. And of course, we generate we return an HTTP 201, and also we generate another JSON with the result. So if you take a look at that one, so here is a sample JSON payload that we're going to be sending on our service. And if we try to hit our endpoint, what's going to happen now is that we return our ID and we return our name with it. So if we change this, so if we this time send Joanne, we're going to get, sorry about that. We're going to get Joanne now. So lastly, we have an endpoint that fetches our record. And how we do that is similar. So this time, we're getting the ID from our path parameters. So this is very similar to how you build a route in Rails, wherein you can embed a parameter in the path. This time, instead of making an insert call, we're going to be using a select call. We are explicitly specifying the names of the columns we want to return, also because the position is very important to us. And one thing to note as well is that the parameter we are passing is a string, but it is a UUID inside of Postgres, so we're going to be casting it as a UUID. Again, we execute a statement, we get the result, the first record, and if we have a record, we return that result as an HTTP 200. If not, we return it as an HTTP 404. So if we try this, so we get the ID and the name again. One thing to note that is because this is a serverless project, we don't need to worry about scaling this. So let's say, for example, if I want to try to simulate some level of load in our services, we could do it via Apache Bench. And for this scenario, I'm going to try to introduce a concurrency of 10. So here we're trying to fetch a certain record 100 times, and we're trying to do it concurrently in batches of 10. So think of it as your your service is being hit by 10 consumers immediately, and as you can see, it's the response is 321 milliseconds, and this is not the actual response of the service. This includes SSL handshaking, as well as the time to actually fetch the the JSON result. If we take a look, at our Amazon console, you can see that the average duration is around 65 milliseconds. There's a max duration of 770, but that's a caveat that I'm going to be talking about shortly. And even if we try to hit it with around 100 concurrency, the the response times would not change by a lot. So okay, let's now move to caveats. So there's a cold start for for AWS Lambda. So our service instances are ephemeral or transient in nature, and our provider, which is AWS in our case, will often turn off instances after a certain amount of activity. It takes a significant time, usually 400 to 700 milliseconds, to spin up a new instance. But the solution to that one is to keep our Lambdas warm, and there are plugins in the serverless framework ecosystem that do that. Another caveat is that serverless is bad for persistent or long-lived connections. So if we're using a traditional database and not the RDS or all serverless, using the data API, each concurrent instance will be using a DB connection. So imagine if we try to hit our service with 500 concurrent requests, that's going to try to attempt 500 DB connections. And we all know that a DB connection is very expensive. So the solution to that one would be to use serverless database as well. And in our scenario, we're using the AWS Data API. So that's it. So here are the links to the demo, the Serverless framework, and Docker as well. Thank you.
Thank you very much. Our speaker forgot to introduce himself. It's Erol Fornoles. It's at Erol on GitHub. That's our last talk for the night. And we have programmer food at the back, so please help yourself. And this is a joint event with the Hangathon. So the Hangathon finalists will be presenting their applications. So please stay and watch their demo. And let's hang out over there.